All right, on to the last page of our notes. We're going to do 3 examples. 2 that are just solving equations and 1 that's a application problem. So, example for part A. Notice that the polynomial is in standard form on this left-hand side, and on the right-hand side we have it equal to 0. What we're going to do is I'm going to outline some steps that you're going to go through when you're solving equations by factoring. So steps that you're going to take to solve equations by factoring. The first thing that you're going to do is you're going to set it equal to 0 if it's not already equal to 0. And for part A, it's already equal to 0. You're going to also put it in standard form. That's going to be useful. Put it in standard form, because when we're factoring, we'd like to have it in standard form. Now, after you have it equal to 0 and you have it in standard form, you're going to factor it completely. But remember, the first step is to look for a GCF. So I'm going to put GCF question mark. Look for a GCF first. And finish the process of factoring completely. So set it equal to 0, factor it completely, and then you're going to set each factor equal to 0. Set each factor equal to 0. Those are really your steps. So set it equal to 0, factor it completely, set each factor equal to 0, using that 0 product property. Okay, so part A, it's already equal to 0, it's already in standard form. We're going to factor it completely by first looking for the GCF. Now notice we have a factor of 2, 2 and 8 are both divisible by 2, and both of them have a factor of x. So we take out the GCF, which is 2x. We take a 2x out of the first term, we have an x remaining. If we take a 2x out of the second term, we have a 4 remaining. Now when we say take out, we're talking about divide, right? So we're dividing out. We're taking the 2x squared and we're dividing it by 2x. We're taking the 8x and we're dividing it by 2x. Right? So what remains? X plus 4. Right? Okay. Now, set each factor equal to 0. 2x equals 0. I could just say x equals 0 at that point, right? Because if 2x equals 0, that means x is equal to 0. X plus 4 equals 0. Subtract a 4 from both sides. X would have to equal -4. So we have our two different solutions. X equals 0 and x equals -4. All right, part B. Write down the polynomial 6n squared equals -15n minus 19, or minus 9, sorry. 6n squared equals -15n minus 9. The difference about this one is I don't have it equal to 0. So my first step is going to be to rewrite the equation so that I have a polynomial equaling 0. So I'm going to add a 15n to both sides, and I'm going to add a 9 to both sides. Okay. Now notice what we can't do is combine any of these terms because none of them are alike. So we have 6n squared plus 15n plus 9 equaling 0. So first step, set it equal to 0. We've got that done. Now we're going to factor that quadratic. Do you see a GCF? That's the first thing we're going to look for. Yes, 6, 15, and 9 are all divisible by 3. So we're going to factor out a 3. So 6 divided by 3 is 2, so we have a 2n squared. We divide 6n squared by 3. 15n divided by 3 is 5n, and 9 divided by 3 is 3. So we factored out the GCF. We need to see if we can factor the polynomial that is inside the parentheses. So A is 2, C is 5. I'm just going to focus on this. I'm going to ignore the 3 for now. In fact, I could divide both sides of this equation by 3 and just throw it away. What we can't do is divide both sides by a variable, but we can divide both sides by a constant, like a 3, because 3 by itself is never going to equal 0. So with this quadratic, A is 2, B is 5, C is 3. We're going to take A times C, which is 6, and we're going to find 2 factors of 6 that will add up to 5. They're both going to have to be positive, right? 6 is 2 times 3, It's also 1 times 5, but 1 plus 5 is 6. 2 plus 3 is 5. So there's the factorization that I need. I'm going to use my table method. So I'm going to draw a table. I'm factoring 2n squared plus 5n plus 3. So the 2n squared gets the first square, 3 gets the last square, and the 5n gets to be broken up as 2n plus 3n. We're going to look for the greatest common factor of the top row. That's going to be 2n. We're going to look for the greatest common factor of the bottom row. It's going to be 3. We're going to look for the greatest common factor of the first column. It's going to be n. And the greatest common factor of the second column, that's just a 1. 2n and 3. GCF is 1. Okay, so that means my polynomial is going to factor as, so my 2n squared plus 5n plus 3 is going to factor as n plus 1 times 2n plus 3. Now we'll apply the zero product property. 3 by itself is not going to equal 0, but the n plus 1 can equal 0. And the 2n plus 3 could equal 0. This will happen when n is negative 1. Subtract a 1 from both sides, you get n equals negative 1. For this one, subtract a 3 from both sides and divide both sides by 2. So we get two solutions to the equation. N equals negative 1 or n equals negative 3/2. And those are the two solutions to our polynomial equation. Okay, I'm going to pause the video, and you are going to pause the video, and we're going to get solutions to the monitoring progress. You're going to check your answers for those. All right, I have the solutions for the monitoring progress written on here, and we're going to dive into example 5, modeling with mathematics. So what we have is a picture of model of an arch of a fireplace using the equation y equals negative 1/9 times x plus 18 times x minus 18, where x and y are measured in inches. The x-axis represents the floor. So this is the floor, right? Here's the floor. X-axis is the floor. The arch, the yellow arch, represents the cutout for the fireplace. Find the width of the arch at floor level. So we're supposed to find the distance from that point to that one, because that's going to be the width of the arch at floor level. We're trying to find this width right here. So what we're going to do is we're going to use the x-intercepts. Remember, the x-intercepts are the places where the graph crosses the x-axis. And these 2 points right there and right there are the x-intercepts. Notice they happen when y equals 0. So we need to know when y is 0. So use the x-coordinates of the points where the arch meets the floor to find the width. So at floor level, y equals 0. So we're going to take the equation that we were given, replace the y with the 0. Oops, that's an 18. And we're going to solve that equation. Now, zero product property says in order for that product to equal 0, either x plus 18 equals 0 or x minus 18 equals 0. Subtract an 18 from both sides of this one, we get x equals negative 18. Add an 18 to both sides of this one, we get x equals positive 18. What that tells us is the x-coordinate of this point right there, that x-intercept is negative 18. And this x-intercept over here is positive 18. If we find the difference between those, the bigger one minus the smaller one, that will give us the distance, or we could just do distance of 18 plus distance of 18 and find that the width is 36 inches. And we're done.